So let's see some of the process. So process is any change that a system undergoes from one equilibrium state to another is called a process. Any change. Path is like the series of states through which a system passes during a process is called the path. So we can say path, the path of the process. Like we have process, so the process follows a simple route, so we call that route a path of the process. So we have the first one, isochoric, which is constant volume. As you can see before and after, even the pressure increases, still the volume is constant, like here volume 1 and volume 2, so we call this isochoric or constant volume. And the second one is isobaric or constant pressure. Here the mass maintains a constant pressure in the cylinder before and after, so we can say there is a constant pressure but still the volume varies, V initial and V final. As you can see here, V final is greater than V initial, but still there is what? Constant pressure. We call it isobaric. The third one is isothermal or constant temperature. Isothermal means, as its name indicates, like the temperature is constant. So we can say the temperature here and the temperature is similar, even though the pressure is different and the volume here and the volume here is different, but still the temperature is the same. So we call it isothermal. So we've seen three processes. The first, isochoric means constant volume, isobaric means constant pressure, isothermal means constant temperature. Now let's see the laws of thermodynamics. Actually we will see in detail, but this one like a highlight for this slide, but as we go through the slides we will see the different laws of thermodynamics in detail. But the first one, we have Zeroth Laws of Thermodynamics. It's all about concept of thermal equilibrium, but I want you to have in your mind, you must play the game. This is like analogy for this law of thermodynamics. And we also have First Law of Thermodynamics, concept of change in energy. You can win the game. You can win the game. Energy in, there is energy out. There's always laws, right? And another one is Second Law of Thermodynamics. This one is all about concept of change in entropy. You can break even in the game. And the Third Law of Thermodynamics, concept of absolute entropy. You can't quit the game. So we will see this in detail on the next slides. So the first one is Zeroth Law of Thermodynamics, right? This one is like, if A is in thermal equilibrium with B, let's say we have three object A and object B, and this is thermometer C. So if A is in thermal equilibrium with B and B is in thermal equilibrium with C, then C will be in thermal equilibrium with A. Like let's say this one, if A is in thermal equilibrium with B and if B is in thermal equilibrium with C, it's obvious C will be in thermal equilibrium with A. In other words, all three systems have the same temperature. We call this thing Zeroth Law of Thermodynamics. So if object B and R each in thermal equilibrium with object C, then A and B are in thermal equilibrium with each other. Allows us to define temperature relative to established standard. So it could be in terms of Fahrenheit, Celsius, or degree or Kelvin, but it's about this. If you have three objects A, B, C, if A and B are in thermal equilibrium, and if B is in thermal equilibrium with C, then C is in thermal equilibrium with A. I think we're going like two objects are separated in thermal equilibrium with a set of they are in equilibrium with each other. If two objects are separately in thermal equilibrium, this one and let's say object 1 thermometer, if two objects are in thermal equilibrium with the third object, they are in equilibrium with each other. So objects in thermodynamic equilibrium have the same temperature. So this indicates the concept of thermodynamic equilibrium, the Zeroth Law. Now this one is you can win, the concept of First Law, you can win. So this is all about what? The First Law of Thermodynamics is an extension of the law of conservation of energy, an extension of the law of conservation of energy. So the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. So we have this internal energy equal to the heat added to the system is Q, and also we have the work done by the system, W. So the difference between those two things, we call it internal energy. The heat added to the system minus the work done by the system.